So this is our test demonstration for Mammoth Aerospace with Yudhishthir Kumar, Zubin Carvalho, Isaiah Suso, Francis James Adeliga, Alexa Hadley, Vivian Zhao, Sky Koltanowicz, Franco Duval, Levi Shane, and Aaron Ma. Sadly, due to a variety of different COVID quarantines, procedures, so on and so forth, the CubeSat has not been in a position for the last few weeks where all of us simultaneously have been able to test it and demonstrate it. So instead, during this test demonstration, we're going to go through a walkthrough of what our plan is to demonstrate it. All the software and the hardware has been coded already, but the live demo will probably have our actual demonstrations, so on and so forth. So the CubeSat design follows the schematics that were provided. The Raspberry Pi is hosted on 4 plastic mounts attached to the bottom of a plastic mounting case. GPIO pins 1 through 4 are connected to the IMU, which measures acceleration, stability, so on and so forth. The No IR camera V2 is connected via its own special connector to the Raspberry Pi as well. It's connected via a USB-C to USB cable into the power bank, and the power bank is charged via connection to a solar panel. And of course, there's 4 sides of plastic paneling all around. The camera itself points down and is housed in a plastic casing. Our software architecture is basically such that we have a program hosted locally on the Raspberry Pi called camera.py. It takes pictures with the camera itself. We control the camera via SSH from the ground station. So whenever we want to take a picture with the camera, we simply run the Python script to take a picture with that camera, manually transfer the file over from the Raspberry Pi to the ground station, and then we analyze it with OpenCV. Our scripts for analyzing images at this point consists of basically analyzing different kinds of color contrast. So in this specific example, we are looking at a red cup on a white background. And what we do is we take this image, we port it over into OpenCV, we mask it, add a bunch of different traffic guards to basically isolate the color we're trying to find, such as red. When we test stuff against a blue background, we try to identify colors. We don't try to identify colors so much when we're looking at plastic bottles. We try to identify different levels of saturation, so on and so forth. And what we're looking for is if the color maps are able to basically discern or look like they are concentric to an object, like it's a closed object and not just some weird thing floating in space.